When you think about high-tech car parts, especially something as critical as brake pads, you probably imagine advanced synthetics, maybe metals. But what if I told you a key ingredient could come from trees?
It sounds a bit strange, but that's exactly right. We're talking about cellulose fiber, which is essentially derived from plant pulp. It's becoming a really important material as the auto industry pushes for greener, more sustainable components.
So the industry is actively seeking out these greener alternatives, and this plant-based cellulose fiber is playing a bigger and bigger role. You're saying it's not just a simple filler, but it actually acts as a reinforcer for strength, is part of the friction material itself, and on top of all that, it's biodegradable.
Exactly. It's like finding a natural assistant for the brake pad that both helps build the foundation and joins in the work of stopping the car. And the best part is that it's an eco-friendly choice. It's really reshaping how we think about brake pad performance and cost.
Okay, so beyond being green and providing that basic strength, what other specific contributions does cellulose make to the brake pad's performance and the manufacturing process?
Well, think of it as the brake pad's weight loss specialist and heat shield. Because it's so lightweight, it helps reduce the overall weight of the brake pads, which can actually improve the vehicle's fuel efficiency and handling. At the same time, its thermal insulation properties help reduce heat transfer to other brake components, keeping things cooler.
That makes sense. So it's helping on the road, but what about on the factory floor?
On the production line, it's also a huge help. It improves what's called green strength, which is the material's integrity before it's fully cured. It also helps stabilize the mixture and even makes the whole process smoother. Plus, that elastic fiber structure you get from cellulose can contribute to better comfort and less noise when you hit the brakes.
It sounds great, but I'm guessing it's not a perfect solution. What are the main advantages and, more importantly, the key limitations of using cellulose fiber?
You're right, there's a trade-off. In a nutshell, it's cost-effective, it's green, and it definitely makes the brake lining stronger. But you have to be careful when things get hot or wet, because that's where it can, falter a bit.
You mentioned it can falter, and I see here it starts to decompose at around 200, 250 degrees Celsius. And for a brake pad, that sounds like a pretty low temperature threshold. Does that mean in an emergency stop or during heavy repeated braking, the performance could be seriously compromised?
That's exactly the challenge. This risk of thermal fading is the main hurdle engineers have to overcome. It forces them to get really clever with the overall formula. They have to blend the cellulose with other high-temperature resistant materials or even apply special coatings to the fibers themselves to compensate for that natural weakness. It's all about making sure the brakes are reliable under all conditions.
I see. So it's a balancing act. It really shows the art of materials, science balancing high performance with sustainability.
Precisely. Cellulose fiber brings sustainability and cost-effectiveness to the party, but its success completely depends on how well engineers manage its limitations, especially with heat and moisture. To sum it all up, it's a key sustainable material that acts as both reinforcement and a friction component. The benefits are clear: weight reduction, better insulation, and easier processing. But the whole thing hinges on intelligently designing the brake pad formula to work around its low heat resistance and sensitivity to moisture.